For centuries, we looked up at the stars and wondered what lay beyond our world. We sent probes to the edge of our solar system, touching the boundaries of the cosmic ocean we call home. But what if we dared to go even further? What if humanity set its sights beyond our galaxy itself? Could we ever escape the Milky Way? Could we voyage to distant galaxies light-years away? Or are we trapped here forever? To understand why leaving our galaxy is such an extraordinary challenge, we first need to grasp just how impossibly vast it is. The Milky Way is a barred spiral galaxy containing somewhere between 100 and 400 billion stars. It stretches approximately 100,000 light-years from edge to edge. That means even if you could travel at the speed of light, the fastest speed possible in the universe, it would take you 100,000 years just to cross from one side to the other. Our Sun sits about 26,000 light-years from the galactic center, nestled in a minor spiral arm called the Orion Spur. To put this in perspective, Voyager 1, humanity's most distant spacecraft launched in 1977, has traveled for nearly 50 years and is now about 15 billion miles from Earth. That sounds incredible, right? But that's only about 0.002 light-years. To reach even the nearest star beyond our Sun would take Voyager over 70,000 years at its current speed. We're not just talking about crossing oceans anymore. We're talking about crossing an abyss so vast it defies human comprehension. Humanity has accomplished extraordinary things in space exploration. We've walked on the moon. We've landed rovers on Mars. We've built a permanent orbital laboratory. We've sent the Voyager probes beyond the heliosphere, the protective bubble of solar wind that surrounds our solar system. In 2012, Voyager 1 became the first human-made object to enter interstellar space. It's currently traveling at about 38,000 miles per hour, faster than any spacecraft we've ever built. And yet, it hasn't even come close to leaving the Milky Way. At its current speed, Voyager 1 would need approximately 450 million years to reach the edge of the Milky Way. We've touched the stars in our imagination, but in reality, we've barely left our cosmic doorstep. So why can't we just build faster spacecraft? Why not accelerate to incredible speeds and leave the galaxy behind? The answer lies in the fundamental laws of physics. According to Einstein's theory of special relativity, nothing with mass can travel at or faster than the speed of light, approximately 186,000 miles per second, or about 670 million miles per hour. As an object approaches light speed, something bizarre happens. It requires more and more energy to accelerate. In fact, reaching exactly the speed of light would require infinite energy, which is impossible. But even if we could somehow reach 99.9% of light speed, there's another problem: time dilation. At near light speeds, time passes differently for the traveler compared to those who stay behind. An astronaut traveling to another galaxy might experience only decades of travel, but thousands or millions of years would pass on Earth. You could leave the Milky Way and return home, but everyone you ever knew would be long dead. Entire civilizations would rise and fall while you were gone. The universe has a speed limit, and it's enforced by the very fabric of space and time itself. But what if there were ways to cheat? What if we could bend the rules, rather than break them? Scientists and science fiction writers have proposed several theoretical methods to escape our galaxy. Let's explore the most fascinating ones. In 1994, physicist Miguel Alcubierre proposed a solution to Einstein's equations that could allow faster-than-light travel without actually breaking the light speed limit. The idea: instead of moving through space, you compress space in front of your ship and expand it behind you, essentially surfing on a wave of spacetime itself. The spacecraft stays still relative to local spacetime, so you never technically exceed light speed, but you could cross vast distances in remarkably short periods. The catch: this would require exotic matter with negative mass energy, something we've never observed and may not exist. The energy requirements would be astronomical, possibly requiring the mass energy of an entire planet or even a star. What if, instead of traveling the long way, we could take a shortcut? Wormholes, or Einstein-Rosen bridges, are theoretical tunnels through spacetime connecting to distant points. Think of them as cosmic shortcuts. If traversable wormholes exist, you could theoretically enter one in our galaxy and emerge in another galaxy, millions of light-years away almost instantaneously. The problem's: we've never found a wormhole. Creating one would likely require exotic matter. And even if we could create one, it might be wildly unstable, collapsing the instant anything tried to pass through. If we can't cheat physics, perhaps we can simply accept the journey will be long, very long. Generation ships would be massive, self-sustaining spacecraft housing entire communities. The original crew would never reach the destination. Their children wouldn't either, nor their grandchildren. Dozens, hundreds, or even thousands of generations might live and die aboard the ship before it finally reached another galaxy. These ships would need to be entirely self-sufficient ecosystems, with recycling systems for air, water, and food. They'd need protection from radiation, meteor impacts, and equipment failures over timescales of millions of years. Could human society remain stable and purposeful over such vast timescales? Could we maintain the technology and knowledge necessary to complete the mission? It's not just an engineering challenge, it's a psychological and sociological one. None of these methods are within our current capabilities. Some may be impossible, but they represent humanity's refusal to accept limits. So, what lies beyond the Milky Way? What would we find if we could escape our galactic home? The nearest major galaxy to ours is Andromeda, located about 2.5 million light-years away. It contains approximately 1 trillion stars and is actually moving toward us. In about 4.5 billion years, Andromeda and the Milky Way will collide and merge into a new galaxy, though our Sun and Earth will likely survive the encounter unharmed. Beyond Andromeda lies the Local Group, a collection of more than 80 galaxies spanning about 10 million light-years, all bound together by gravity. But here's where things get truly cosmic, and perhaps a little melancholy. The universe itself is expanding. And not just expanding, accelerating. Distant galaxies are being carried away from us by the expansion of space itself, faster than light could ever catch up with them. There's a cosmic horizon beyond which galaxies are receding so quickly that their light will never reach us. This means that the vast majority of galaxies in the universe are already forever beyond our reach. No matter how advanced our technology becomes, no matter what breakthroughs we achieve, entire regions of the universe will remain eternally inaccessible to us. The universe is vast beyond imagination, but it's also a prison of sorts. A prison of physics, distance, and time. Even if we could leave the Milky Way, we could only ever explore a tiny fraction of the cosmos. Most of the universe will remain forever unknown, forever out of reach, hidden behind an insurmountable barrier of expanding space-time. Are we prisoners of our galaxy, or are we explorers fortunate to have an entire galaxy to call home? Throughout history, humans have been told what's impossible. We were told we couldn't cross the oceans. We did. We were told we couldn't fly. We did. We were told we couldn't reach the moon. We did. Perhaps biological humans will never leave the Milky Way. Perhaps our lifespans are too short, our bodies too fragile, our technology too primitive. But what about our descendants? What about artificial intelligence carrying our knowledge and values? What about future civilizations that might unlock technologies we can't yet imagine? What if we could upload human consciousness into forms that don't age, don't need food or air, and can survive the endless void between galaxies? The dream of leaving the galaxy isn't really about escaping, it's about reaching. It's about the fundamental human drive to see what's over the next horizon, to touch the unreachable, to make the impossible possible. Even if we never leave the Milky Way, the mere act of dreaming about it pushes us forward. It drives our science, our technology, our imagination. Because the story of humanity has never been about accepting limits, it's been about asking, what if? So, could humans ever leave the Milky Way? With our current physics and technology, no. The distances are too vast, the speed's too slow, the challenges too immense. Maybe we're confined to our galactic island forever. Maybe the universe is simply too big for any species to fully explore. But maybe not today doesn't mean never. The same species that once huddled in caves now sends robots to distant planets. The same species that thought the Earth was the center of the bared universe now understands its place in an incomprehensibly vast cosmos. Perhaps one day, in a future we can barely imagine, our descendants, whether biological, digital, or something entirely new, will look back at this question and smile. Because they'll be out there, among the stars of another galaxy. The story of humanity is the story of what happens when we look at the impossible and say, let's try anyway. Would you dare to be part of the journey? Subscribe and explore the unknown with us.